So we're going to be looking at, so I'm just going to go through the notes a bit so that those who didn't read these notes can also understand what's going on, right? Now, if we look, I also included the definition of in most of these, I included the definition of a linear map, right? If we check here, so we are told that a linear map or a linear transformation is a function T such that V maps to W between two vector spaces V and W that satisfies these two conditions, right? For all these and some scalar C. We can say maybe a scalar C element of F if we're looking at this over some field F. Now when we come to the kernel, we say that the kernel is also called a null space, right? We know how we find the kernel. I said that we're going to be using this format always. The kernel of T is also V element of V, meaning that we're taking an element from the domain, right? We take an element from the domain, and then we say such that we take the image, we equate it to 0. Then this 0 here should be based on the codomain. What is the space of the codomain? So we'll see that. Now, when you come to the image, which is range, we say that T is equal to, or the image of T is equal to, here remember I said that some books use the image. They say image of T, right? So we're going to be using that. Now, we say is also the image such that V is an element of V. Then when we come to the nullity here, we talk about the dimension of the kernel. How many elements are inside the kernel? And the kernel, for us to find this dimension, we must express the kernel in form of a span. You see right now, for us to find the dimension of the kernel, we must express this in form of a span. Now, for us to find the rank, we're going to find the dimension of the image, but mostly the image, we're not going to use it that much. We're going to familiarize ourselves with this formula. We know that rank plus nullity will be equal to, let's say, M, given that this is the dimension of V. Was that map the dimension of this, right? Now, or we call that N. It's up to us. Now, if you know this one, the dimension of this one, you'll always know. If this is R squared here, it means that the dimension of this here, we're going to have 2. Then the nullity, we just find the kernel. If we find 1, it means that the rank will be 2 minus 1. You see, right? Then we get that. So it will be simple for us to find the rank in most cases. So we just look at that. Now, we say that for a matrix A representing T, kernel is the null space. And here we did mention that kernel is the null space. Then the image is the column space. And rank is the number of linearly independent columns. For now, we're not going to be using matrices. We'll use matrices when we meet on Wednesday for a cross night, right? When we do these questions in detail. For now, I'm just going to show you using these normal methods. And the nullity is the number of free variables in AX. Likely, we've spoken about free variables and so on. So it will be simple for us to discuss that. Now, we come to key properties. The key properties, I think we've discussed these. Our focus will just be here now. We've discussed these key properties. Let me not dwell much into them. We also have these theorems that I said you can look at, right? Based on if in class they did do them or not. So I'm going to look at those theorems. Now, for the verification methods, check this. For us to find the kernel, we must solve TV is equal to 0. You see, right? Or AX is equal to 0 based on the type of question that we have. And we must express as a span. We must express this as a span. We're going to express it as a span always. Now, to find the image, we determine the span of TV or columns of TV or of A. The columns of A or... So let's say now, instead of now we're only going to discuss this method. When we meet, we'll discuss this one of matrices, right? if we're discussing this one, it means that we must determine the span of TV. Then after determining the span of TV, that's when we can determine the image, right? Then if we're using this method, it means that for us to check the image, we must determine the columns of A. Now, to compute rank and nullity, we'll look at these ones of matrices, but for now, I'll show you how do you compute ranks and nullity using this method, right? Ranks and nullity. So, let's see. We have example 1. Example 1, I just included this, right? Just to give you a clue of what's happening. But then let me just create a page and then I'll show you how do you answer a question like this. Yeah, the question is, they say we should find the kernel if t such that r squared goes to r is defined by txy, which is equals to x plus y. Now let's see how do we find the kernel, right? So now let's say this. Now, first thing that you do when you want to find the kernel, right? So we must come and say the kernel of this function. If it was f, I was going to say the kernel of f. So this is the kernel of t. Is because then I pick an element from r squared. The element should be what's inside here. It's xy, which is an element of r squared. This is coming from the domain, such that I take this element equal to 0. But I have to decide what 0 is this. What is the space of 0? I check on the other side, the codomain. I have one space, so it means that this one is just going to be 1, 0. Like that. You're going to get a mark for this. The moment you mess up here, you see right now? The moment you mess up here, yeah, you're done. Now, from here, we say this. We say that, remember guys, you're not going to change this part. This part is going to remain the same. You're only going to change the such that part. This will remain the same. This side, you equate your t of xy. Your t of xy is this, is x plus y, which is equals to 0. Then you proceed to say this is x, y element of r squared, such that x will be equals to minus y. So what did we find here? We found that we're going to replace y. Always replace the second one. If you're having two of these, replace y by x. Always express everything in terms of x. If it's like this, it means that x is equals to, it means that minus x is equals to y. If I divide both sides by negative, meaning that I'll replace this by minus y. You minus x, man. You see right now? I'll replace that by minus x. And then I say such that I no longer put this. Because now I'm writing the solution that I get here. Such that x is an element of r. I must define the variable that I have there. Now, this is our kernel. This is the solution that we wanted, but we need to express it now as a span. If I express it as a span, it means that I'm going to remove the variables now. If I remove x there, I'm going to get 1 minus 1. Then I close. Then this is our kernel. We are done for this question. Now you see why the kernel was the span of 1 and minus 1. You see right now? Now, you see that. Let's look at the second one. Or let's look at this question. The same question. Let's say now they say we should find the nullity. Who can tell me what would be the nullity here? One. Because the vector that we have inside the span is 1. You see right now? The nullity is 1. If we have the nullity which is 1, what will be the rank? Would come and say what will be the rank here? Who can tell me by looking at things what will be the rank?
1.
1, right? Let's check. Nullity, rank plus nullity. Actually, I should have said nullity of T. Nullity of T, which is equal to the dimension of what? What is our domain here?
2.
R squared, right? Yeah, the dimension of that, dimension of R squared, which is 2, right? And then it means that, let's see, our nullity, we know it's 1. The dimension here, it's 2. It's going to be this, right? 2. Then we have plus the rank of T. Meaning that our rank is going to be 2 minus 1, which is equal to 1. So that is correct. We agree. So for each question, we're going to check what is the rank, what is the dimension, so that you can get used to. Even though the question wanted a kernel, we're going to check all, right? So let's look at the second one, a second example. And they say find the kernel. Oh, let me not say find the kernel, because we know we must find the kernel. I'm just gonna take this function from R3 R2 such that T of x y z is equal to x y. Then I copy this, right? Now we want to find the kernel first, right? We say that the kernel of T will be equal to, we say what? We first let an element to be an element of R3, meaning we're going to take this 3, x, y, z, to be an element of R3, such that we take T, for the function T, x, y, z, to be equal to, we must let this be equal to 0, but the 0 must be coming from this. It's a 2D space, so it's going to be 2 zeros. So we have x, y, z, element of R3, such that our T, x, y, z is x, y, which this is equal to 0, 0. Then we solve. We're just gonna solve it there without changing this side. X is equal to what? 0. Y is equal to 0. Then now we check the solution that we got. If x is 0, meaning I'll replace x by 0, y is 0, z remains the same. You see, such that we only have z left. So we're going to define z. Z is an element of a real number. So here we have the span already. We know what is the span. The span we're going to have, we have 0, 0, 1. We just take out that z. You see, right? That's why here our span was, let's check what is our span, 0, 0, 1. That's why you see that right there. So meaning we can even get our nullity of T is going to be the dimension of the kernel of T, which is 1. And if we look at the rank of T, what do you think will be the rank of T? Let me zoom out so you can see everything. The rank of T will be what?
2.
2, right? Meaning that the rank of T will be 2. Do you agree there, right? Ne? So using the formula would get that. Now let's say this now. Let's look at the third one. On the third one, we have T P1. Okay, let me copy it such that P1 maps to R such that T of A plus BX is equals to A. They say we should find the kernel, right? They say we should find the kernel. So let's see what we're going to find. So now we have this. We're going to do this. We're going to say for the kernel of T, remember we must let this to be an element of P1. So we're just gonna let A plus BX be an element of P1 such that now we take T of A plus BX to be equals to 0, but then on the other side it's only one space, right? So we're just going to say equals to 0. Then we continue to solve. A plus BX element of P1 such that this is A, this is equals to A, which is equals to 0. We have solved this already. So according to this, if we plug our 0 here, we're going to get BX. Let me just define also here such that B is an element of, and we can say that this is a real number. You see, right? Now let's see. We have this. What do you think our span will be here? The span will be what? Guys, you're always going to remove the one that is here. You see these ones, you're always going to remove the constants. When you remove the constants, what are you left with? When you remove these things, in polynomials, you're only going to remove these, let's say, B. If you have B, you're going to remove them. What do you get here? You have A, B, C in polynomials. You're not going to remove things like X, Y. They need that here. Remember in polynomials, we can even have 1, X squared. You agree, right? Ne? To be the standard basis. Do you agree that? Or to be vectors in polynomials. Do you agree, guys? But
Yes.
but we can have things like B as vectors. You agree, right? So it means that the thing we should be left with here is X. That is the span of this one. That's why here, if you check, we had, let's see that question. We had X as the span here. This is how we're gonna do things in polynomials. All right, let me see if we have another polynomial here. This one, I think we're left with one here. Another polynomial, let me check if we can find another one. We can't find another one. Yeah, we can't find another one here. Yeah. No, can't find another one. It's fine. So, but you see, right now. So now let's come to this one. We'll find the kernel, right? Oh, before we find the kernel on that one, let's check here, because I can't skip this without finding the other ones I forgot to. We must find the nullity. What will be our nullity here? One, right? Our nullity is 1 because we only have one vector inside. Now, did I say rank of kernel? Yeah. Then now we come and check the rank. The rank of T plus nullity of T will be equals to the dimension of P1, because the P1 is our domain, right? What is the dimension of P1? What is the dimension of P1? 2, right? Then our nullity is 1. It means that our rank is what?
1.
It's 1, right? Now, let's go back and confirm our rank. I want us to confirm our rank, right? Here we say that it's going to be 2 minus 1, which is 1. Let's use a different pen to confirm our rank. There's a condition that says that our image is going to be equal to this. Do you agree there? That the image, there's a condition that says that the image of this will be equal to the codomain. In this case, our codomain is R. Meaning, in other words, it means that the rank, if we were going to use this, the rank would be the dimension of R. You agree, right? And what is the dimension of R? The dimension of R is what?
1.
1. All right. So that's why here our rank, we got 1. You see, right? If we're going to use the same thing here, the same approach to find the rank, it means that we would say that the image of T is equal to R squared, which means that the dimension of R squared is equal to 2, and this is the rank. You agree, right? Ne? Meaning, if we check the rank here, we found 2. You see, right? Ne? Now, we come to this one. The rank, we found 1. But if we check here, the image of T is also R, meaning that the dimension of R is 1, and that is the rank. So it means that here we found that our rank is 1. So that we can always confirm the rank, right? Ne? So in linear transformation, this is simple to confirm. That the only difference will come where we're going to use matrices. Things may differ, or they may vary at some point, right? So for now, it means that if you were looking for the rank, you didn't have to go through all the steps. Just that I wanted to show you everything. You could have easily got this, but I like the steps where you have to show everything, right? And using this formula is nice. It shows that you really understand. Then, now let's go to the ones of matrices. We have this one now. We're given T such that M2 by 2 maps to R such that T of A, B, C, D is equal to A plus D. They say we should find the rank. Let's see what we can find. Let's see what we can find. The rank is becoming simple, right? We're going to say we must find the kernel first. T is equal to, we let A, B, C, D. We use the same format to be an element of M22, such that T of A, B, C, D is equal to 0. But we check the other side. What is the space? It's 1. So we're going to have 1, 0 there. Then this is equal to, we keep this as it is. Then here we have, this is A plus D, which is equal to 0. Then we have A, B, C, D, element of M22, such that A is equal to minus D. You see, right? Now, since we have this, now we can go and see what we found here. We're going to replace D by A. So it means that this would be A, B, C minus A, such that A, BC is an element of a real number. Do you see that? Do you see that, guys?
Yes.
Yeah. So I always replace the one which is coming after the first one. Then we say, now if we're looking for span here, how many elements do you think we're going to have inside the span?
Four.
Saying 4 elements.
I say 3.
Another one is saying 3.
3.
3. Why are you saying 3? And the one who's saying 4, why are you saying 4? So we look at this. Remember last time I told you, you look at this when you're spinning, right? You look at the variables here. How many variables do we have now?
3.
3. It means that they're going to be 3, right? So we start with A. We ask ourselves, is there an A here? Yes, right? Here there's no A. Here there's no A. And here there's A. It's -1. You see, right, ne? Then we come to the second one. We look at B. There's no B here. Here there's B. There's no B. There's no B. Then we look at the last one. We look at C. There's no C. There's no C. There's no C. There's a C. Do you agree that these will be our elements, right? Ne?
Yes.
Then what is the nullity here? What is the nullity of T?
1.
She's saying it's 1. Do you agree? Another different one? We have 1, another option. Or do you all agree on 1?
3.
Another one is saying 3. Another different option?
I say 3.
Also is saying 3. Why are you saying 3? What's the reason you're saying 3?
Isn't the thing supposed to be the amount of elements in the span?
Yeah, the number of agree dimension, we know that is the number of vectors in a basis, right? And a basis is a subspace of a vector space. So let's come to these key properties. The kernel of T and these are what? Subspaces, right? So it means that the number of vectors found in these things is going to be our dimension. You agree, right? Ne? So it means that our dimension is going to be 3. The correct one means that it's 3, because we have 3 elements. 1, 2, 3. You see. But if they are the same, remember on test 1, I realized something. On test 1, some of you got the dimension to be 5. But in truth, the dimension was 3. Because there were 3 elements that were looking the same there. Am I lying? There were 3 elements that were looking alike, right? If elements are the same, you count them as 1. You see, so you got 5 things there in the span, but then you're in the basis, but then you didn't manage to check that they are the same, so you're gonna count them as 1. So the nullity is 3. What would be the rank here without using that formula? Let's look at what would be the rank. The rank would be the dimension of what? The rank, guys.
Of image. Dimension of image.
What is our image here?
1.
So is just this, right? Ne? So it's 1, right? Yeah. And how do you confirm that? The dimension of this is what? Of M22. The dimension of M2 is 4. So 4 minus 3 is 1. You agree, right? Ne? So without using the formula, you would be able to see that there's indeed like that. So do we agree on this? We say that they're not difficult as they looked, right? Or as they seem. So now we know what is that, how we found that. Now let's look at this. Let's do this last one, then we stop here. I think I've explained enough. It's possible to get a trivial solution, right? Let's do this last one. Now, for the kernel of 2, we're going to have xy being an element of r squared such that t of xy will be equal to what? 2 zeros, right? Because here it's r squared, you say, right? Then this will be xy element of r squared such that this is 2x 2y equals to 0 0, and this is xy element of r squared such that x is equal to 0, y is equal to 0. When they're all equal to 0, guys, this tells us that we're getting this. Do you agree with me there? X and y are 0, right? So this is the same thing as having 0. If this is 0, what is the nullity? The nullity is what?
0.
0. And then what would be the rank? The rank will be equal to the dimension of r squared, right? Which is 2, because nullity is 0. So if nullity is 0, it means that the rank is equal to the dimension of this. This occurs when we're having a 2 by 2, let's say, instead of a 2 by 2, let's say a linear operator. I must remember what is a linear operator, right? You remember what is a linear operator, guys? When the domain and the codomain are the same, there's a linear operator. You see, right now? Yeah, so I think I've given you enough information. I just wanted to give you this information. I was not gonna do corrections of the problems. So you can even look at these images. As I was explaining, the image on these ones is very simple. You realize already the image is simple. You can look at the image. Then you look at the rank. The rank is here. I just found everything, right? You look at the rank. What is the rank? You confirm. And it's possible to get the rank to be 0. You look at that. Then when you come to these ones of matrices, oh yeah, we have, yeah, let me look at these ones for matrices. Let's just look at one of it, right? Maybe if not one, let's see. This, we have that A is equal to 1, 2, 3, 4, 5, 6, 8, 9. But let's reduce this. Let's just reduce this. Want to change this to 0, 0, right? So this is row 2 minus 4, row 1. This is row 3 minus 7, row 1. Can someone use a calculator to check this? I don't have a calculator with me here. Or let me use a normal calculator here to see. The one on the internet, to see what we get.
Minus 3.
You get what? Let me just plug it there first.
It's minus 3 minus 6.
Oh, actually, here's what we get. You're going to calculate yourself, right? Let's do this. But on the cross night, we're going to do everything. We get this. If we put it to reduced, we get this. How many leading ones do we have here?
2.
Sure.
2. 2 leading ones, right? Let's go back to our original, from the beginning of this page, of this document. Let's see. We say that the image is the column what? Space, right? And rank is the number of linearly independent columns. Linearly independent columns are those with leading ones. You agree, right, Nick? And we say the nullity is the number of what? Of free variables in AX equals to 0. So this is our AX equals to 0. So it means that in matrix form. So if we come and check, we have 2 linearly independent you see, right? Meaning the rank of T will be equals to 2. And free variables, how many do we have? 1. So meaning what is the nullity?
1.
1. You see, right, ne?
What do they mean when they say free variables?
Free variables is those ones without a leading one, meaning they can take any value. They are free variables.
Oh, yeah.
Yeah. We can, if we come to solutions, we might find that we may have many solutions or no solution. But this one is considered to be many solution. You see, right now? So it can take any. If here it's Z. If Z is 3, we're still going to have 0 here. It won't change anything. You see, right now? That's why we call it a free variable. So we're going to discuss this. You can just look at them here. At least I've shown you what do you check, right? You're going to check what is the rank. Like here, if you check here, how many leading ones do we have here? It's 2. What is the rank? 2. You see, right? Then look at this. How do we confirm this? Remember the formula is saying a rank of T plus nullity of what? T, which is equal to the dimension. This will be equal to the dimension of this one, R4. And how do you know this dimension? Is this the row or the column? Do we count the row or the column here?
Column.
Columns. So we have 4 columns. You agree? Even if without checking this, we have 4 columns. 1, 2, 3, 4. 4. And the rank is 2. How many free variables do we have? 1, 2. These ones, they don't have leading ones. So it's 2 plus 2, which gives us 4. This is correct. You say right, ne? Then we come back here. How many columns do we have here? If you want to 3 columns, right? If you want to confirm if your solutions are correct, no, it's rank of A, not T, but it's fine. You will see that. Then the nullity of A, which is equal to the dimension. Or if we don't know what it is there, you just say 3, right? Because the columns are 3. Then the rank, we know it's 2, and the nullity, we found that we only have one free variable, which is 1. So this is equal to 3, which is correct. You see, right? Ne? So you're always gonna confirm like that. So these ones of matrices, they are very simple. As long as you know how to do row echelon forms, reduce, and those ones we've been doing them all along. You agree, right? Ne? So it's going to be simple. So any question?
No question.
No question, right? So yeah, you can look at that. You try to solve them and see what you get. Yeah, you see, even the analysis one, we have found that. Then on this one, they say find the nullity of T for the 0 map from TRN to RM, where the dimension of V is N, meaning the dimension of this one is N. And then the nullity of T will still be N there. Then the dimension of the what will be the rank here in this question? M, right? So yeah, something like that. Let me see, where is that question? We don't have it here right now. Yeah, we don't have it here, but it's fine. Yeah, you can, guys, please try to do these ones of the surjective. Okay, for injective and surjective, right? These ones already I've shown you how to find the kernel and the image and so on. So what you can do here, just come and look at this. This, what I gave here. T is injective if the kernel is 0. You see, right now? If you solve the kernel, you find 0. And then T is surjective if the image is equal to W, and all along when we were solving those ones of linear map, we're using this to be equal to this. You agree, right now? We're considering a map to be a linear T to be surjective. You agree there, right now? And then if T is an isomorphism, it means that it should satisfy a linear map and also should satisfy this two. Then it will be isomorphism. So these ones are all here. So you already know how to do them. You just check the kernel, you check the image. If the kernel is 0, you know it's injective, right? If the kernel is not 0, it is not injective. Then you do this. So these are based on what we've been doing before. So we may decide on that. And then what do I want you to do right now? We'll have another session later, around 7 again. We discuss these solutions, these problem solutions. So everyone now knows how to do them. So I'm going to stop this recording. I'll only, as usual, I'll only send the link to those who wrote. Then the rest will get the recording tomorrow, maybe when I'm done writing, right? So make sure you write so that we don't keep you out.